This is a Sales Geek Academia to Business Translation production. Welcome to the Deep Dive. Today, we're tackling something every sales leader grapples with: sales forecasting. You know that feeling, right? That knot in your stomach when the forecast is way off?
Oh, absolutely. It leads to all sorts of problems: warehouses overflowing, production scrambling, or maybe even worse, missing out on huge opportunities because you just didn't see the demand coming.
Exactly. It's this constant challenge, accurately predicting what's next. People often talk about it like it's some mix of art and science, maybe a bit of gut feeling thrown in.
A bit of intuition. But the thing is, the precision of that forecast, it affects practically everything: production, capital, the company's success, even your own career path, frankly.
And that's where things get interesting. We've relied on traditional methods for ages, time series models, regression analysis.
Right, the standard toolkit. But let's be honest, they often fall short. They really struggle, especially with capturing the complex, nonlinear stuff that happens in real-world sales data.
The market isn't a straight line, is it?
Not at all. And sales definitely aren't either. So using tools that, well, fundamentally expect straight lines, that's pretty limiting.
Okay, so that sets up our mission for today perfectly. We want to bridge this gap between the, let's say, cutting-edge academic research on sales and the practical day-to-day reality for sales leaders like you listening.
Yep. We're going to translate the complex stuff, ditch the heavy jargon, and use some real-world examples from a pretty fascinating recent study.
We're focusing specifically on a research paper that dives deep into using machine learning ML to really boost forecasting accuracy. And it uses a case study from Mahram Food Industries.
That's right, a big food manufacturer. We'll explore how these more advanced algorithms can give you a much better handle on navigating the unpredictable world of sales. It's about empowering better decisions, really.
So let's dig into that core challenge first. Why is forecasting so hard? Is it just complex numbers, or is it deeper?
It's definitely way more than just crunching numbers. Accurate forecasting. It's foundational. It guides, well, almost everything strategic: production schedules, inventory levels, budgets, growth plans.
Right.
And think about a company like Mahram in the study. Established back in 1970, huge range of products. Mayo, sauces, jams, juices. For them, demand can swing wildly. So many factors influence it.
It's like a whole ecosystem of influences.
Exactly. You've got internal things and external things constantly interacting.
Yeah, the research mentions a ton of factors. Internally, okay, you've got your past sales data, obviously. But then there's marketing, pricing, your product mix, distribution channels.
All the levers you can theoretically pull. But then you layer on the external stuff, the things you can't control. Competitors launching something new or dropping prices.
Economic shifts, consumer confidence going up or down.
Market trends, seasonality, even legal changes or new tech can mess things up. It's complex.
So the big question becomes, how can those older traditional methods possibly map all these intricate, often nonlinear connections or adapt quickly enough?
And the short answer is, well, they often just can't. They miss the nuances. They can't really handle the dynamic nature of it all effectively.
Which leads us nicely to the solution explored in the paper: machine learning. Now, machine learning might sound intimidating.
Yeah, people hear that and think black box, maybe.
Right. But think of it maybe like a super smart apprentice. You don't program every single rule. You feed it data, lots of data.
Historical data, market info.
And it learns. It finds the hidden patterns, figures out what drives sales, and uses that to predict what's coming. It learns without being explicitly told how for every single scenario.
Exactly. And the study we're looking at didn't just use one technique. It cleverly combined a few things. Yes, time series modeling was still in there, but integrated differently. And then the big guns: machine learning, specifically neural networks and random forest methods.
Okay, let's break those down a bit. Neural networks.
Think of them maybe like a simplified brain,
Yeah.
interconnected neurons forming these complex nonlinear graphs. They don't just look for straight lines in the data.
More like squiggly lines. The messy reality.
Precisely. They learn to draw the best possible line, even if it's very complex, through the data during training. They can capture those really subtle, unpredictable patterns that older methods just completely miss, like recognizing a face from different angles.
And they have multiple layers, right? Does that help?
It does. It helps them handle complex interactions between inputs. And crucially, it helps avoid a big problem called overfitting.
Overfitting. That sounds bad.
It is. Imagine a model that's perfectly memorized past sales data, but is useless for predicting the future because it's too rigid, too specific to the old data. It hadn't learned the underlying patterns, just the noise. Neural networks, especially multi-layered ones, are generally better at generalizing.
Okay, that makes sense. And random forest, what's that about? Sounds like something out of Lord of the Rings.
Huh, not quite. Think of it as wisdom of the crowd. It's what's called an ensemble learning method. Instead of relying on one model, it builds lots and lots of individual decision trees.
So like little mini forecasters.
Kind of. Each tree gets trained on a slightly different random subset of the data and makes its own prediction. Random forest then combines the predictions from all these different trees, often by averaging them.
So you get a more robust, stable forecast.
Exactly. It's much less likely to be thrown off by weird outliers or biases from just one perspective. Its strengths are high accuracy, it's robust, handles nonlinear stuff well, and importantly, it's less prone to that overfitting issue we just mentioned.
And I heard it can tell you which factors are most important.
Yes, that's a huge bonus for sales leaders. It can provide feature importance scores, basically telling you which variables, maybe a specific marketing channel or pricing or competitor activity, have the biggest impact on the forecast. That's super valuable for focusing your efforts.
So how does this learning actually happen? What's the process?
It generally follows a few key steps. First is data collection and preparation. You gather all your relevant historical sales data, plus data on those influencing factors we talked about, internal, external.
Cleaning it up, getting it organized.
Crucial step. Then you split the data. You use most of it for training, that's what the model learns from, and you keep a separate chunk aside as testing data the model has never seen before.
Why separate it?
To see how well the model really performs on new, unseen situations. It prevents the model from just memorizing the training data. It tests its actual predictive power.
Got it. Then what?
Then comes model selection and training. You choose your algorithm, neural network, random forest, whatever fits best, and you let it learn from that training data. It adjusts its internal parameters to minimize errors and make better predictions.
And finally?
Model evaluation and tuning. You test the trained model on that unseen testing data, see how accurate it is. Then you can tweak its settings, its hyperparameters, to try and improve performance further. It's often an iterative cycle: train, evaluate, tune, repeat.
Okay, that makes the process clearer. Now, let's tie this back to the Mahram Food Industries case study. This wasn't just theoretical, right? They actually did this.
Absolutely. They applied these advanced methods to Mahram's real sales data. Mahram provided the data, which is pretty groundbreaking in itself for this kind of combined approach in their specific sector.
And the goal for Mahram, with all their different products and influences.
The goal was ambitious: to create a really comprehensive forecasting engine, something that could handle the complexity, account for all those variables, internal, external, investor perspectives, and ultimately help them optimize everything from production to strategy. Predicting future sales more accurately was the core challenge.
What kind of models did they actually implement in the study?
For the neural network part, they used something called a nonlinear autoregressive model with exogenous input, NRRX for short. Fancy name, but basically means it looks at past sales and those external factors to predict future sales.
So it considers context, not just history.
Precisely. And they used a common training algorithm called backpropagation neural network, BPNN. Think of it like a tutor guiding the network, correcting its errors, helping it learn to minimize the difference between its predictions and the actual results.
And how did they use the data? You mentioned training and testing.
They were quite rigorous. They used 945 data points for the initial training, then 185 separate points for validation, sort of fine-tuning during training, and another distinct 185 points purely for the final testing.
So a good amount of data to really check if the model worked.
Definitely. It ensures the evaluation is robust, that the model isn't just getting lucky on one small data set.
All right, the moment of truth. What were the results? Did machine learning actually win out?
This is where it gets really compelling. The study directly compared the neural network's performance against the traditional methods, the ARMA time series model, and multiple variable regression, apples to apples.
How did they measure success? What are the key numbers a sales leader should care about?
Good question. They used a few standard metrics, but let's simplify them. First, absolute deviation, MAD. Basically, on average, how many units was the forecast off by? Lower is better, obviously. Less error means less waste, better planning.
Okay, straightforward.
Then there's MADI percentage, MADP. It's just the MD expressed as a percentage of actual sales.
Okay.
Gives you a relative sense of the error. Again, lower is better.
Makes sense.
And finally, mean squared error, MSE. This one penalizes larger errors more heavily. So a model with a low MSE is not just accurate on average, but it also avoids those really big, costly mistakes. a sign of reliability.
So lower MAD, lower MADP, lower MSE. That's the goal. What did the Mahram study find?
The results were pretty clear-cut. The neural network significantly outperformed the traditional methods on all those metrics.
Significantly, like how much better?
Okay, let's look at MAD. The neural network scored 28.33, multiple variable regression was 28.54, and time series was worse at 29.45. So consistently lower error for the neural network.
Noticeable, yeah. What about the percentage error, MADP?
Same story. Neural network, 10.2%. The others were 10.35% and 10.38%. Again, the ML model edged them out.
And MSE, the one that penalizes big mistakes.
Even clearer there. Neural network MSE was 6.472. Regression was 6.472. And time series was way higher at 7.8865. That suggests the neural network was not only more accurate on average, but also more reliable, less prone to those big misses.
Wow, okay. So it's not just marginal improvements. These numbers suggest a real advantage.
Absolutely. It's a measurable, significant gain in accuracy and reliability.
So let's translate that. For the sales leaders listening, what's the so what? Why should they care about these lower error rates?
It means much more trustworthy forecasts. Plain and simple. When your forecast is more accurate, you have a much stronger foundation for making all those critical decisions we talked about earlier.
Like setting sales targets.
Exactly. Realistic targets.
Yeah.
Making smarter hiring decisions based on projected growth. Optimizing budgets, knowing how much marketing spend is needed, for example. Planning inventory levels more precisely.
Like Mahram figuring out their juice production for the summer.
Precisely. Imagine doing that with much higher confidence, minimizing waste, ensuring you meet demand. That directly hits the bottom line. Better forecasts lead to better strategic planning and ultimately more profitable outcomes.
Okay, so the potential benefits are clear. What were the key lessons learned from doing this project with Mahram? What insights can other sales organizations take away?
Several big ones emerged. First, and maybe most fundamentally, the absolutely pivotal role of data. This wasn't just about reporting what happened. It showed data is the essential fuel for prediction. Good strategy needs good data.
So investing in clean, organized, accessible data isn't just an IT thing, it's a core sales strategy enabler.
100%. The quality of your data directly limits or enables the accuracy of your forecasts. Garbage in, garbage out still applies, even with fancy algorithms.
Or else?
Understanding feature importance. We touched on this with Random Forest. The study showed ML can reveal which factors actually move the needle on sales.
Moving beyond just gut feel about what matters?
Exactly. It allows sales leaders to stop guessing and start focusing resources, time, money, effort on the drivers that have the most impact. Is it that new campaign? Is it competitor pricing? Is it seasonality for this specific product? Data can tell you.
That sounds incredibly powerful for resource allocation.
It really is. Another key lesson was the need for continuous improvement. Forecasting isn't a one-and-done task.
Not set it and forget it.
It's definitely not. Markets change, customer behavior shifts, new factors emerge. Your models need to be updated, retrained with new data, and fine-tuned regularly to stay relevant and accurate. It has to be an iterative process.
And the final lesson.
This one's crucial. The human-AI partnership. The models are powerful calculation engines, but the study stressed the need for business understanding.
So the sales leader's experience and knowledge are still vital.
Absolutely essential.
Yeah.
You need that domain expertise to interpret the model's outputs correctly, to sanity check them, and to decide how best to apply those insights strategically. It builds trust and leads to better decisions.
It's about collaboration then. Sales working with data science.
Yes, interdisciplinary collaboration is key. It's not about AI replacing sales leaders. It's about AI empowering them with better tools and insights.
Okay, this has been incredibly insightful. Let's boil it down. If a sales leader listening wants to start moving in this direction, what are, say, 3 concrete, actionable takeaways they can implement?
Okay, 3 key actions. Number 1, prioritize data quality and accessibility. Seriously focus on capturing good, clean, relevant historical sales data, plus those internal and external influencing factors. Make it organized and easy to access for analysis. That's the foundation.
Makes sense. Get your data house in order first. What's number 2?
Number 2, shift from guesswork to data-driven insights on drivers. Use analytical tools, maybe start simple to really understand what specific factors are driving your sales. Don't just look at overall trends, know your levers. This lets you allocate resources much more effectively.
Focus on what actually works based on evidence.
Got it.
And number 3?
Number 3, embrace iterative forecasting and strategic integration. Treat forecasting as a living, ongoing process. Set up a regular rhythm to review accuracy, feed in new data, refine your methods, and critically, integrate those data-driven insights directly into your goal setting, your budgeting, your overall strategy. Make forecasting an active tool for growth, not just a report.
So data first, then understand the drivers, and finally make it an ongoing, integrated strategic process.
So it sums it up nicely.
So as we wrap up, here's a thought to leave you with. How can you leverage these kinds of advanced analytical approaches, this partnership between human insight and machine intelligence, to transform your sales function? Moving it from being reactive, always trying to catch up, to being truly proactive, a strategically guided engine driving predictable, profitable growth for your business. This has been another Sales Geek Academia to Business Translation production.